Hey y'all, thanks for joining me today on this video. Today we're going to make a Softwash mixing valve, and you can see I've got a stainless steel header here. This is off the shelf. Tell you where to get some decent deals on the GF valves, and why I'm not installing check valves, at least for the moment. So anyway, stay tuned and I'll tell you all about how to build this and how much it costs. Alright, so we're going to build a Softwash mixing valve. Some people call them proportioners, and I think proportioner has a lock on that name. So anyway, they're actually a mixing valve, and they start with a header. So that might be you buying polypropylene crosses and then putting street 90s in it and putting your valves on it, which is just fine. Just remember that you have basically two half-inch lines running into half-inch. So there's really not enough room in that pipe for two half-inch lines to properly mix, in my view. And that's why there's manifolds. So a lot of people build their manifolds out of 3/4 inch PVC or polypropylene and then put the two half-inch valves on it, which that's probably more of a proper header. If you have a manifold even like this that has all the same size fittings on it, so let's say this is ½ inch and all this is ½ inch, this would be more considered not a manifold but a T of some sort. So anyway, a manifold, you got all these ½ inch lines dumping into a larger line, and then that makes it all work better. And I was just about ready to build a PVC one, and I did some more searches through images, and this one caught my eye, and this is made by HomeFlex, and this is 3/4, and these outlets here, or inlets, whichever way you're going to run it, are ½ inch iron pipe size, so they're threaded. So this is exactly what a lot of people are building, but in a more compact size and also less fittings. And it's really a beautiful piece. The stainless steel feels like it's about 15 thousandths of an inch thick, this main body here, and these takeoffs are awesome, heavy. These inserts right here are heavy, they're real thick, and they're all laser welded. I'll try to get a better photo, but they're all laser welded. It's a beautiful piece of work, and they're only $16 at Home Depot or online. So I'll leave the part number down in the description, or you can just search Home Depot stainless steel manifold and these will come up. And if you walk into your Home Depot, just go back to the corrugated stainless steel tubing, which is the flex gas lines, and these will be in a box. So I just walked into my local Home Depot and bought it. The price is just crazy. So next would be valves. So I think most everybody in the business know that they love the GF valves. They don't love the price about them because they're about 125 bucks a piece, but they do flow a little bit more than these Pentair valves right here. So I originally bought these Pentair valves actually thinking both of these brands, when in the full open position, was wide open gate. So ½ inch in, ½ inch through, ½ inch out. Same way with these. That's what I considered a metering ball valve, which that's the family of what these are called. This one more than this one, but this will show up on a metering ball valve, but it's not a ball valve at all. So in the wide open position, you can't see through it. So it's not like a traditional ball valve with a V groove cut out of it. And I understand there are some like that, but they're like $350 a piece. So here's the Pentair. These are actually a compression valve. There's a plunger that goes up and down. And in the open position, you can't see through this either. Both have restrictions, and I know that by just opening them up and blowing through them hard. And then do the same with your other valve. If you have them both, you can tell there's quite a bit of restriction. And I didn't look up the specs or anything, and I'm not going to do it because both these valves are working in the field, so I'm not really going to question that. But this one to me feels like it's about 30% restricted when I blow through it, if I was just guessing. This one feels about 40% restrictive. So this may be why essentially they're running half the volume they could actually be putting out, being a wide open gate. When you're running everything in ½ inch, that everything seems to work. A lot of people go, oh, I got ½ inch and it works just fine. So maybe if these were wide open gate where they're flooding full ½ inch of water, 2 inlets into 1/2 inch pipe, then there's an issue there. The next thing I want to talk about is check valves. I believe this is a Pentair check valve. There's several polypropylene check valve companies, and I think even Banjo makes one. So this is ½ inch iron pipe, and so when I got these, I blew through these. These are about 30 to 40% restricted. So now you take this and you put it here, and no wonder that a ½ inch line can now take the output of these valves. When you put them, you know, in series with a check valve, you're dropping a lot of flow. So that's another reason why a full ½ inch system seems to be working in the field. But so I'm going to tell you why I'm not going to use check valves in the beginning. And obviously I have the check valves. I figure once I'm done using the Softwash system, I just come over and turn all the valves off, and as I'm going, the sloshing in the tank won't try to mix inside my header. But as long as there's a vacuum on here, like when I have my pump on and it's pulling, there'll be no way anything could mix in here. And so when I'm done, just to keep anything from mixing back into the tank, I'll turn all these valves off. And I don't know if that's going to be a pain or what, but if I can get another 3, 4, 5 feet on the end of the gun, then that might be enough someday for me not to get a ladder out. And you see some of the guys on the videos online, they're showing them soft washing, and they're standing on their tippy toes with your arm all the way out. And on those days, if you could, you know, take care of the little things on the front end, maybe at the end of the gun you get another 4 or 5 feet, which might get you to that spot you need to get to. Anyway, so I'm going to start putting this together and show you how to put pipe dope on a nipple. Okay, before we get started here, we're going to gussy up these valves. So the only issue I see online, the majority of the issues, is this fitting cracks. Well, it's obvious why it cracks, because, you know, this is a tapered thread here, and there's a tapered thread in here. So the way they seal is they compress against each other by being an incline here, tapered. And so when you tighten it up so tight, I just tighten it up by my hand, and you can see it starting to flare up right there. So I can see why you're having issues with that. So this appears to be made out of polypropylene, and this GF valve is a harder material, and I'm assuming that's PVC. So another reason why this valve is more expensive. Not to mention that it has 2 unions on it, which makes it easy to service and replace. This one, not so much. I'm having a feeling that once I get all this together, and if these ever have any problems, I'm just going to go ahead and buy GF valves. So what I'm going to do is tighten this clamp up and keep it close to the edge here. So because you don't want to put the clamp down here, because that's not where it's going to do its business right there. So you want your insurance policy down on that end where it'll easily spread apart. Keep it right next to the end. Okay. So continue to put some pressure on it. Okay. Pretty tight. So now when we put this fitting in, it shouldn't go near as far, and it'll keep this from, splitting. So I think you guys with these valves, they're probably either already split or going to split. So you may end up just, buying you some worm clamps and, helping yourself out by doing that. So anyway, that's just a little tip. All right, so also I want to show you guys how to dope pipe threads. Pipe dope is it's every bit of lubricant as it is a sealer. So once you put these two tapered threads together, there's not much room left for pipe dope. So what I see online is this. People are just dabbing this on there like it's gluing it on there, and it's not. So what you need to do is like this, and I mean that's all you need right there, just a thin layer. And you only have to dope your male fittings, and this is your True Blue. There's different brands of it, but it's good to have it made for a plastic pipe and metal pipe. It somewhat sets up a little bit, but it never gets hard, as opposed to some that never sets up at all. So you'd want to make sure you're starting, correctly, and then you'd thread that on there. So anyway, I'm kind of getting ahead of myself, but I'm just showing you a way to make your Pentair valves last a little longer. All right, so here's the name of the manifold. It's Home Flex, and what I'm using is 3/4 by 3/4 by half. Home Depot SKU number is this. If you're getting half by half by half, Home Depot SKU right there. And like if you're going to run a gas pump, this would work really good for a gas pump. You got 1 inch by 1 inch by 3/4 inch takeoffs, and there's the SKU for that. Now it appears that most Home Depots have the one I purchased in stock. Some have the 1/2 inch. Not many have the 1 inch, but in just a few days you can get that shipped to you. And you can also find it online from other companies other than Home Depot or other sellers. So the GF metering ball valve, which is, here's the part number to it, and these run about $125 on Amazon. All right, so we're going to use a combination of these 1/2 by 5 inch nipples, and this is stainless steel, and this shoulder nipple, 1/2 inch shoulder nipple. I get the shoulder nipples so I can get my pliers right here, and it gives a little room between fittings if you need to get a pair of pliers in to just unscrew this. So if you get a close nipple, that'll be threads all the way across, and you won't have much of a room to get your pliers. So I usually always buy shoulder nipples. All right, so we're going to start down here with our short valve, and we're going to install it. And it's easier to install the nipple and valve at the same time and work your way down, and you'll have to alternate lengths. So this first one here is going to be the 1/2 inch, and so I'm going to put my pipe dope on, as you can see, just like that. That's all you need. And I'm going to go ahead and dope this side here. Just like that. So it's going to go down at this end. And although I'm holding it in the vise, I'm not going to put these nipples in without putting a backup wrench here, even though I holding this body in the vise would probably do it. You never want to do that. You always want to put a backup wrench on. All right, so I'm going to put a backup wrench on here, my channel locks, and I'm going to get on this, and I'm going to loosen this up. All right, then I'm going to take my valve and put it on there. I think I'm going to have it orientated where this is up this way on this side. So kind of shake it a little bit. Make sure that you're not cross-threading it, that it goes on finger tight. And now it's just a matter of how tight do you want it. So I'm going to go that tight. So the thing about plumbing is, if you crank this thing as tight as it'll go, then if it does leak, you can't go any further. So my dad taught me that in plumbing. He says tighten it up, you know, decent. That way, if it doesn't leak, you're good. And if it does leak, you have another turn or two left in it. But don't take that away from yourself when you very first put a fitting together and crank it all the way, because it could have stopped leaking a turn or two ahead of that. So the next one would be the longer one. All right, so I'm going to dope up this 5-inch nipple. Again, we're not doing this. That's not the way to do it, guys. And I've already got this side done. So we'll tighten this up, same as the other. Okay, sometimes you'll leave a little sharp area here where your pliers dug in. So just take your pliers back over, take that roughness off, just like that. So again, this is another Pentair valve, orientation up. Just kind of going by feel, guys. All right. So you see, I didn't put a wrench on there, and it's really tight for a piece of plastic. So if it does leak, I'll go another turn. But right now, I don't know if it's leaking or not. All right. So the next one would be a short nipple. Okay, we're going to tighten it up same way. We're going to take the half union here off of this valve, and this is where having a valve with unions built onto it will make your life a little easier. It's too bad they have to cost $126. So this one will need to be tightened up. I have nothing to grab onto it with. So again, I didn't put it on very tight. All right, so we're going to put the last nipple in, and we'll tighten that up. Take that next valve, take the union off of it. Make sure it started right. You know, I guess you could take and, well, no, you can't put a, I was thinking you could put a worm clamp on there, but you're not going to get this nut over unless you put it on afterwards. But no one seems to be saying they have an issue right here of these splitting, so I'm not too worried about it. All right. So the great thing about the unions is now you can insert your valves. It's easier if you weren't trying to keep everything in frame here and make a video. So that's basically it. Both these valves are bi-directional. They'll work either way. So there's no inlet or outlet to them. All right, so now let me tell you why I used the higher priced GF ball valve, metering ball valve for the water, because most generally everybody turns their water completely on. So this could have been just a regular $6 ball valve, or if you want to pay 15 bucks for a stainless steel ball valve for the water, because it's normally either off or on. But I decided that was a problem because these valves have restrictions in it. So if I'm running 12.5% chem through here, SH, and I want a 6 1/4 mix, then I have this valve open all the way, I have this valve open all the way. So if they're both identical valves, then I'm going to get a proper 50-50 mix right here. And so that helps me with these degrees that this ball valve's open. So it's a lineal graph on this ball valve. So all the way open, running both of these is 6 1/4%. If I go in between, and I can't see it from here, whatever that number is, in between, then that's 6 1/4 divided by 2, so that's 3 1/8, and then so forth and so forth. Well, I couldn't do that if this ball valve here was a regular ball valve letting through a full amount of water, non-restricted, and then if I open this up all the way, and if this was a regular ball valve all the way, I'm not getting a true 6 1/4% by diluting my SH down 1-to-1. So that's why I put the more expensive one here, so I don't have to, fiddle. If I want 1.5%, I'll be able to come up with a number quickly for that. Now over here, this is my detergent, soaps, surfactants, whatever you want to call it. I think it's good. I've got an extra port here. A lot of them, they just use 3 ports and they put their soap in here. So this way I can have my my valve here that's not as accurate and maybe not as good as these valves, but all I'm doing is pulling soap through it. So this one may be hooked to, say, an F9 product. I think it's good to have a little flexibility like that, because now I can have 2 different soaps hooked up at the same time, or let's say this valve messes up, I can put the hose to here or whatever. Also, I'm picturing on my trailer, and it could be either way, but picturing my trailer that the pump's over here pulling, and so I'm going to have this here. So this will be here pulling out. Also, I have this port here. Now you can just take and and plug those if you want, like that. And you could plug this fourth, port on here too if you just want to run 3. But I thought, well, how cool would it be if I just pull a 3/4 line off of here and then run this here to here and put a inlet on my trailer like this, where I can pull from a batch mix, I can pull water, or what I'm going to use it for is a transfer pump to bring my SH up, and it's going to go across here and it'll go through the pump, through the 3-way valve, and go either in my tank as a transfer, of chemicals, or go into the hose reel. So that's my end thought. And I'll show a video of that together, but that's still kind of in the making. But if you just wanted to put your own fittings on here, have at it. Put a plug in here. I'm also going to have, the 1/2-inch lines coming off of the main valves, and then I got 1/4 inch for the soap, and I also have 3/8 for the soap. And just looking at it, it looks like 3/8 is way better than bringing it down to 1/4 inch. But so put whatever fittings you want on there. The whole build itself with the stainless steel nipples was around $335. Now I know a lot of people and companies sell these for like $5 something. That's not really that bad of a deal, especially if you don't have the time. This is the middle of January, so I've got the time, but it takes a lot of time to get all this together. Now it won't take you near as long, because you can go to Home Depot and order all this stuff, and in a week have everything sitting at home, and and really in an hour have it together. But I like building stuff and saving a little money, but I guarantee you I would give anybody $250 that would order all this stuff in, and I didn't have the time, and it'd be well worth it. So that's about it. Stay tuned on my next video where I hook the motor in and hook all my this is going to be my transfer of SH onto the truck into my tank. In a manifold built like this, you eliminate a lot of fittings, a lot of places where you're going to cause restriction and turbulence. So basically, these are dumping off in this big manifold. There's hardly going to be any restriction. It's going to come in here in free flow, but you can still consider these an elbow. So you basically are going to have each valve go through one elbow to get to the pump. Now I've got this where it's going to go directly in here with a couple of cam locks. So this is, once it gets into the header, it's going to go straight through the pump, straight out of the pump. And the only part I'm going to put an elbow on basically is this 3-way ball valve. So it's going to be the only place I'm going to have some restriction. But it is 3/4 inch. This pump is 1/2 inch. So I've got 1/2 to 3/4 banjo fittings instead of 1/2 to 1/2. And to be real honest with you, the 3/4 inch fittings have a less than 1/2 inch hole in them. So by using 3/4 inch fittings, you're actually just continuing the 1/2 inch product. When you use 1/2 inch stuff, then you're dropping this down to 5/16, 3/8 at the max of restriction. So when possible, I would use 3/4 inch